Hello students, the question is the driver sitting inside a parked car is watching vehicles approaching from behind with the help of his side view mirror, which is a convex mirror with radius of curvature r equals to 2 meters. Another car approaches him from behind with uniform speed of 90 km per hour. When the car is at a distance of 24 meters from him, the magnitude of the acceleration of the image of the side view mirror is a. The value of 100 a is. So, this is a problem based on ray optics and some basic use of calculus. So, in this problem, the situation is something like this, that there is a mirror, convex mirror of a parked car, of a parked or a stationary car. This is the convex mirror. Now, there is some another car which is coming towards this car, stationary car. So, the driver inside the parked car or the stationary car is viewing the incoming car, and we have to find out the acceleration of the image in the mirror, which is seen by the driver of the parked car, stationary car. So that's the main problem. Now, to solve this problem, we have to find out basically the acceleration of the image, AI. So first of all, we have to derive the expression for this acceleration of image. For this particular derivation, we have to utilize the basic rule or the basic formula of the mirror. For the mirror, we know that 1 upon V plus 1 upon U is equal to 1 upon F. Now we can differentiate this equation. So after differentiating this equation with respect to time, we get this expression as minus 1 upon V square dV by dt minus 1 upon U square du by dt is equal to 0. Now we can further simplify this expression right in this form, Vi upon Vo, because dV by dt is the rate of change of the position of the image. So it means that this is the speed of the image, and similarly du by dt is the rate of change in the position of the object. So we can call this as Vo. Now Vo is given in this problem, that this the object speed is given. The object in this case is the moving car, and its speed is given as 90 kilometers per hour. We can convert it into meter per second by multiplying it with 5 upon 18. So this value comes out to be 25 meter per second. Now Vi upon V naught, this becomes minus V square upon U square. This is the basic formula which you have to remember in such kind of problems. Now from this expression, from the expression at this stage, we can differentiate it again to find out the acceleration, because acceleration is basically the rate of change of speed or the velocity basically. So the acceleration, to calculate the acceleration, we have to differentiate this equation again. Now writing this equation in this form, that in the form of Vi and Vo, this equation becomes Vi upon V square plus V naught upon U square is equal to 0, where Vi is the velocity of the image, V naught is the velocity of the object, V is the position of the image, and U is the position of the object. Now to differentiate this equation, first of all, we have to remember this expression of the derivative, which is in the form of ratio. For example, we have to find out dV by dt of U upon V. So this is given by, this formula is given by Vu dash minus Uv dash upon V square. This is the formula which is used for the two different functions in the division form. Here U dash is basically du by dt and V dash is dV by dt. So we have to use this particular formula. So using this formula, this equation becomes V square dvi by dt, dvi by dt. We can call this as ai. So this becomes V square ai minus Vi, then 2V dV by dt upon V square and its whole square, then plus for the second term, this is for the first term, For this second term, that is v naught upon u square, the derivative is u square a naught minus v naught 2u du by dt upon u square and its whole square, and this is equal to 0. This is equal to 0. Now, acceleration of the object is 0 in this case. You can easily see that here the object is moving with a uniform speed. This is given in this problem also, that the object is moving with uniform speed. So, uniform speed means the acceleration of the object is 0. So, we have to put here a naught equals to 0. So, after solving and simplifying this equation becomes ai upon v square minus 2v vi square upon v to the power 4 minus v naught square into 2u upon u to the power 4, and this is equal to 0. Further simplifying it and calculating from this equation the value of ai, this value becomes 2 vi square upon v plus 2 v naught square v square upon u cube. Now, let us call this as equation number, I think we have used the equation 1 earlier. So, yeah, this is equation number 2. So, this is equation number 2 ai. So, first of all, to calculate the acceleration of the image, we have to find out vi, we have to find out v, we have to find out v naught. V naught is given basically in this problem. Then u is also given. The position of the object is 24 meter at a particular instant. So, u is also given. So, we have to calculate v here first of all. So, to calculate v, we can use the mirror equation. So, according to the mirror equation, we have 1 upon v plus 1 upon u equals to 1 upon f, or we can say that v is equal to uf upon u minus f. Now, putting the respective values, u is given as 24. Now, the important point here is this, that the ray is incident from this convex mirror from right to left, and the position of the object is rightwards. It means it is opposite to the direction of the incident ray. So, it means that we have to take that value of u to be equal to negative value. Now, f is r upon 2, and r is given as 2. So, f is 1. So, 24 multiplied by 1 upon minus 24 minus 1. Now, solving this value comes out to be 24 upon 25 meters. Now, vi can be calculated from the formula which we have derived earlier, this formula, that vi is equal to minus v square upon u square into v naught. Now, v we have calculated, u we know the value of u is minus 24, and v naught is the object speed, which is 25 meter per second, which we have calculated. So, after putting all the respective values, this comes out to be 24 upon 25 multiplied by 1 upon minus 24 whole square multiplied by 1 upon 25. So, after calculation, we get this result. Now, here v naught is it is not 1 upon 25, it is 25 here. So, calculating it, this value of vi comes out to be minus 1 upon 25. This value comes out to be minus 1 upon 25 meter per second. Now, putting the respective values in the equation which we have derived here, equation number 2. So, we get the acceleration. So, acceleration is equal to, now putting the values, 2 multiplied by minus 1 upon 25 whole square divided by 24 by 25, then plus 2 multiplied by 25 whole square multiplied by 24 upon 25 its whole square divided by 24 to the whole power 3. Now, solving it further, we get the result as minus 2 upon 25. This ai comes out to be, the acceleration of the image comes out to be minus 2 upon 25, and we have to calculate 100a. We have to calculate 100a. So, we have to multiply this value by 100. So, 100 multiplied by minus 2 upon 25. So, this value comes out to be minus 8. So, minus 8 is the value of 100 AI. This is the final answer. The minus sign is there because the in the mirror, in this mirror, this car seems to be moving towards the right hand side, which is opposite to the incident ray. The acceleration is in the rightward direction. So that's why the direction of acceleration is opposite to the direction of the incident ray. That's why the sign is negative here. So minus 8 is the answer. And if we are concentrating on the magnitude part only, the magnitude of 100A, so this is basically 8. So the answer is 8. Magnitude of this is 8. तो यहाँ एक प्रॉब्लम पूछी गई है, इसमें कहा गया है कि एक पर्टिकुलर कार है जो पार्क्ड है, उसमें कॉनकेव मिरर से जो है एक दूसरी कार को देखा जा रहा है जो उसकी तरफ आ रही है यूनिफॉर्म स्पीड 90 किलोमीटर पर आवर से। जब कार 24 मीटर की डिस्टेंस पे रह गई तो हमें मैग्नीट्यूड बताना है इमेज का जो साइड व्यू मिरर में दिखाई दे रहा है और वो है ए। तो हमें 100A की वैल्यू कैलकुलेट करनी है। तो यहाँ सिचुएशन कुछ इस तरह से है कि जो पार्क्ड कार है उसका जो कॉन्वेक्स मिरर है उसमें एक दूसरी कार को देखा जा रहा है और उसका हमें एक्सेलरेशन फाइंड आउट करना है, उसकी इमेज का एक्सेलरेशन फाइंड आउट करना है। तो इमेज का एक्सेलरेशन फाइंड आउट करने के लिए सबसे पहले हमें बेसिक कैलकुलस की हेल्प से जो है इमेज का एक्सेलरेशन निकालना पड़ेगा। हमें इसमें जो स्टार्टिंग करनी है वो करनी है मिरर फॉर्मूले से। मिरर फॉर्मूले की हेल्प से उसका डेरिवेटिव हमने फाइंड आउट किया। तो हमें सबसे पहली स्टेप पे हमें मिली स्पीड और या वेलोसिटी ऑफ द इमेज और उसे हमने एक्सप्रेस किया इन टर्म्स ऑफ द वेलोसिटी ऑफ द ऑब्जेक्ट एंड द पोजीशन ऑफ द इमेज एंड द पोजीशन ऑफ द ऑब्जेक्ट के टर्म्स में उसे डिनोट किया। फिर उसके बाद हमने इसको दोबारा से जो है डेरिवेटिव इसका लिया। दोबारा से डेरिवेटिव लेने के लिए हमने कैलकुलस का जो बेसिक रूल है डिवीजन फॉर्म का जो हमारा डेरिवेटिव का फॉर्मूला है उसको हमने यूटिलाइज़ किया। ये फॉर्मूला हमने यूटिलाइज़ किया इस पर्टिकुलर स्टेप पे। उसके बाद हमने जो है सॉल्व किया। सॉल्व करने के बाद हमारा एक्सेलरेशन कुछ इस फॉर्म का आया 2vi स्क्वायर अपॉन v प्लस 2v नॉट स्क्वायर v स्क्वायर अपॉन u क्यूब। अब यहाँ पे हमें इमेज की स्पीड चाहिए, हमें इमेज की पोजीशन चाहिए, हमें ऑब्जेक्ट की स्पीड पता है, हम उसे मीटर पर सेकंड में कैलकुलेट कर चुके हैं, हमें u पता है। तो सबसे पहला काम ये रहेगा कि हम सबसे पहले v फाइंड आउट करें। तो v फाइंड आउट करने के लिए फिर से हमें मिरर फॉर्मूले की यूज़ करना पड़ेगा। वैल्यूज़ पुट करनी पड़ेंगी रेस्पेक्टिव u और f की विद रिस्पेक्ट टू द साइन कन्वेंशन। तो ये वैल्यू आती है 24/25। उसके बाद हमें इमेज की जो है स्पीड या वेलोसिटी निकालने के लिए फॉर्मूला यूज़ करना है माइनस वी आई स्क्वायर अपॉन यू स्क्वायर इंटू वी नॉट। सारी वैल्यूज़ पुट करने के बाद ये वैल्यू निकल के आती है -1/25। फर्दर इसको हमने सॉल्व किया तो यहाँ से हमारा एक्सेलरेशन जो आता है वो आता है -2/25। इसको हमने जो है 100 से मल्टीप्लाई अगर हम करते हैं तो ये वैल्यू निकल के आती है 8, क्योंकि हमसे क्वेश्चन में 100A पूछा जा रहा है। तो यहाँ पे जो हमारा आंसर होगा वो होगा 8। इसका मैग्नीट्यूड जो है वो 8 मीटर पर सेकंड स्क्वायर होगा। डायरेक्शन जो एक्सेलरेशन की है वो है टुवर्ड्स राइट, फ्रॉम लेफ्ट टू राइट। सो इसलिए हमारा आंसर में नेगेटिव साइन आ रहा है। सो दिस इज द एक्सप्लेनेशन ऑफ दिस प्रॉब्लम ऑफ द सॉल्यूशन। होप यू अंडरस्टैंड इट। थैंक यू।